Hello everybody. Today we will discuss about the new topic that is radioactivity. Actually, radioactivity is the phenomenon of spontaneous disintegration of the nucleus of an atom with the emission of one or more penetrating radiations like alpha particles, beta particles, and gamma rays. The examples of radioactive substances uranium, polonium, radium, thorium, etc. The important point is, which is to be considered, all naturally occurring elements with atomic number which is more than greater than 82, all these elements show radioactivity. Okay, now there are three types of radiations. Number one, alpha rays. Number two, beta rays. Number three, gamma rays. Now we will discuss their properties one by one. First of all, if we talk about the nature, so alpha rays is nothing but the helium nucleus, whereas beta rays are nothing but electrons of nuclear origin, and gamma rays, it is high energy electromagnetic radiations. Second point regarding property is mass. The mass of alpha particle is 6.67 into 10 raised to the power minus 27 kilogram, whereas mass of beta particle is 9.11 into 10 raised to the power minus 31 kilogram. In case of gamma rays, rest mass is 0. Third property is regarding charge. Alpha rays have plus 2e charge, beta rays have minus e, and gamma rays is neutral, that is no charge. Now behavior of the alpha rays, beta rays and gamma rays in the presence of electric and magnetic field, that is the deflection, how they show their behavior. So alpha rays deflected towards the positive pole, negative pole, and whereas beta rays deflected towards the positive pole, or whereas gamma rays shows no deflection. Regarding speed, alpha rays have near about 10 raised to the power 7 meter per second speed, beta rays 10 raised to the power 8 meter per second, whereas gamma rays propagates with the speed of light, that is 3 into 10 raised to the power 8 meter per second. Now ionizing power, alpha rays have 10 raised to the power 4 times that of gamma rays. The ionizing power of beta rays is 10 raised to the power 2 times that of gamma rays, and the ionizing power of gamma rays is minimum. Penetrating power in case of alpha rays is minimum. In case of beta rays, it is 10 raised to the power 2 times that of alpha rays, whereas in case of gamma rays, it is the penetrating power is 10 raised to the power 4 times that of alpha rays. Now effect on photographic plate. Alpha rays have a strong effect on photographic plate, whereas beta rays have less effect, and gamma rays have very minimum effect, almost no effect. Now we discuss about the laws of radioactive disintegration. So Soddy and Rutherford formulated the following laws. Number one, radioactivity is a spontaneous process. Means it doesn't depend upon the external factors like temperature, etc. That is, a radioactive element is in a state of disintegration which depends upon the law of chance. It means it is not possible to predict which particular atom of the radiation will disintegrate in a given time interval. We cannot predict it regarding the which atom, which element will disintegrate first. Okay, it is not possible. It is a just matter of chance. Number 2 point, regarding disintegration of an atom, either an alpha particle or a beta particle is emitted. Both these particles are never emitted simultaneously. Okay, also at a time, an atom will not emit more than one alpha particle or more than one alpha particle. It means in one time one alpha particle is emitted or one beta particle is emitted. Two alpha particles or two beta particles cannot be emitted simultaneously, whereas gamma rays emission follows the emission of alpha or beta particle. Third point is, when a radioactive nucleus emits an alpha particle, its atomic number decreases by 2 and mass number decreases by 4. But when a radioactive nucleus emits a beta particle, its atomic number increases by 1, but mass number remains same. There is no change in the mass number. Next point, the emission of a gamma particle does not change the mass number or the atomic nucleus of the radioactive nucleus. Next point, the number of atoms disintegrated per second, that is rate of disintegration of radioactive atom at any instant, is directly proportional to the number of radioactive atom actually present in the sample at that instant, and it is known as radioactive decay law. Now we will discuss the mathematical form of radioactive decay law. Suppose n naught is equal to total number of atoms which are present originally in a sample at t is equal to 0, and n is equal to number of atoms left undecayed in the sample at that time. Suppose dn is equal to a small number of atoms that disintegrate in a small interval of time, that is dt. So rate of disintegration of the element R is equal to minus dn upon dt. So what is the meaning of negative sign here? So negative sign indicates that number of atom left undecayed decreases with time. When time is increased, the number of atoms which are left undecayed, it decreases. Okay. So according to radioactive decay law, minus dn upon dt is directly proportional to n. To remove a sign of proportionality, we use any constant. Here constant is lambda, or lambda is known as decay constant or disintegration constant. Okay, so we can say dn upon n. This n can be just brought just below the dn, and dt can be taken right side. So dn upon n is equal to minus lambda dt. This is equation number 1. Now we will integrate both sides. So integrating both sides, we get, so dn upon n, its integration comes out to be log n at base e is equal to minus lambda, integration of dt is t, and plus c. C is integration constant. So when time is 0, initially when t is equal to 0, actually we will find the value of c by imposing the initial conditions. When time t is 0, so n is equal to n naught. N naught is the maximum number of atoms which are present initially. Okay, so putting these values in equation 2, so log n naught at base e is equal to, when time is 0, so minus lambda into 0, it comes out to be 0 plus c. So we can find out the value of c. So c is equal to log n naught at base e. Now the value of c from here can be put in equation 2. So we will get log n at base e is equal to minus lambda t plus the value of c we can put here, log n naught at base e. Now after solving, log n at base e, you bring it towards left side, minus log n naught at base e is equal to minus lambda t. So we can say log, this is the formula of log m by n, that is log m minus log n. So we can write it like this, log n upon n naught at base e, it is equal to minus lambda t. Or to remove log from here, we can just raise, we can write the right side in an exponential term. So n upon n naught is equal to e raised to the power minus lambda t. After cross multiplication, we can say n is equal to n naught e raised to the power minus lambda t. This equation represents the radioactive decay law. This is known as radioactive decay law. Now on the basis of this equation, a graph can be plotted, and the graph is like this. Here it is the graph. The graph is plotted between time and number of atoms left undecayed. So initially the number of atoms, suppose, were n naught. Okay, so after half time, that is t by 2, the number of atoms becomes n naught by 2, just half with whatever the present in the beginning. So it becomes n naught by 2 in this duration, in the half time. So we will get a point here. Again, further in half time, the number of atoms becomes n by 4. So the midpoint of from here is this, or in case of 2t by 2 second half, so we will get this point. Again in the next half, it becomes again n naught by 8, so we will get this point, and so on. So this is the graph that we will get number of atoms left with respect to time. So there are some important features of the graph. Number one, the number of active nuclei in a radioactive sample decreases exponentially with time. The disintegration is fast in the beginning. In the beginning, the disintegration is fast but becomes slower and with the passage of time. Okay, so the larger the value of decay constant, that is lambda, the higher is the rate of disintegration. Or last is, irrespective of its nature, a radioactive sample will take infinitely long time to disintegrate completely. So that's all about the radioactivity, laws of radioactivity, and the mathematical form. Okay, thank you and have a nice day.